I don't know. However, there's so far 22 participants, including me. So, however, I think it is, I don't know what is about you. Maybe it may be a busy day or maybe not much busy day for you. However, I think we will start that what is the point that we got stopped. And I noticed that in last week there was some kind of my voice was not clearly heard for you, properly communicate for you, some kind of communication error. I don't know what is that. So if there is any communication issue of my voice is not clear or some kind of issues, please inform me. Please let me know, then I can do some kind of adjustment for that one. Right. Okay. However, I think then before starting, please put your registration number and also your name. Then I can take the attendance. And then I hope now you can hear me properly, right? Can you hear me properly?
Yes, sir.
Okay. Then we will start, right? Okay. Let me share my screen. Then in last week, we started our discussion on cloud computing, and there is some kind of overview that we are going to discuss. And then we discuss about introduction, about computing, and some kind of trends. These are the topics now we are discussing: distributed computing, these things, grid computing, cluster computing, and utility computing, and cloud computing. We will discuss this thing. We are in progressing of these topics. And we discuss about distributed computing and what is centralized versus distributed computing. We discuss and distributed computing systems. What are the examples for the distributed system? We discuss a little bit about AWS and Azure, those kind of thing, right? And computers in distributed system, we discuss common properties of distributed computing. Now I think, and why distributed computing, right? Then we are in this topic, right? Distributed computing. We discuss these topics today, right? I think we stop in this point. Why distributed computing, right? Then next one is distributed application. Right? What is distributed application? Application that consists of set of processes that are distributed across a network of machines and work together and work together as a assemble to solve a common problem. We can define, or we can note that distributed application is some kind of application or set of processes. We can tell a set of processes that distributed across the network machines, right? Let's assume that if you have to do some kind of calculation, what you are doing, right? If you have this kind of 3 server machines, right? Let's assume these are 3 server machines, right? When what you are going to do, right? You are going to share. Let's assume you have a work, right? We discuss here, right? Here we discuss, right? Work one, right? Likewise, we discuss. Then you have a work to do, right? Then you have a work to do. Then what you are going to do, this is W. This is the work we have done. Then we will divide this work into 3 parts: work 1, right? Work 2, and work 3, right? W1, W2, and W3, right? Then what we are going to do, we are going to assign each work for each of the servers, right? Sorry, this is for the second one, right? And third one will be sent into this point, right? Machine work together as an assembler to solve a common problem. Let's assume this is the common, this W means the common problem. This common problem is divided into 3 pieces or parts, and this work is distributed through the distributed computing system. As a distributed computing system, I take 3 server machines, right? Then this work is divided and distributed among these 3 machines that we are having. Then in past, most client server, right? There is a architecture called client server architecture, right? Resource management centralized at the server. We had discussed the resource management or the all services we supplied by a single server, like not like this. This is some kind of distributed server infrastructure, but earlier these things or this client server architecture mean it is one server machine, right? One server machine, right? This is the server, right? One server machine and all clients, maybe mobile phones, computers, laptops, maybe some any other module or device is all connecting to this server machine, right? So in past, most that is this client server architecture mean, right? So this is some kind of centralized architecture that we discussing in the beginning, right? This kind of centralized case, right? Right. And peer-to-peer computing represents a movement towards more truly distributed application. If you are familiar with peer-to-peer, right? Peer-to-peer computing, right? I think you must be familiar with torrents, right? Torrents technology. Some people are use this technology for downloading some kind of documents. Maybe in Sri Lankan context, these torrents are widely used for downloading illegal content, right? Illegal content like unauthorized or unlicensed softwares, right? Like Office or Windows, Microsoft Office package, or maybe Windows, or maybe some any other application that is not properly purchased, right? And also movie downloading, right? Unless without paying for the films, maybe you know now there is a lot of online film platforms are available like Netflix, right? Netflix is some kind of Netflix, you know, right? Netflix, right? It is some kind of a portal or the platform for the movies. If you want to watch film, you can register here and you can watch movies, but you have to do some kind of payment for that one. But if you are using this torrent, right, normally it is not legal, right? There's a lot of new movies and maybe films are available, not only these things, right? A lot of applications, right? But this is not the main idea or the main concept of these torrents. But however, this torrent technology or this torrent, uh, uh, what is we call this ecosystem, this torrent ecosystem is using for this kind of illegal things also, right? So this what I want to tell here is this torrent technology. This torrent technology is a great example for this peer-to-peer computing, right? So also this peer-to-peer computing is, right, we can say it is some kind of truly distributed application, right? It is some kind of truly distributed application, because distributed application mean this software is I think this software is distributed among some kind of network of computers, right? Then all computers are servicing. As example, right? Let's assume you want to download some kind of file, right? Right? 1 TB file, right? From the torrent network, right? That means that is some example for some kind of peer-to-peer network. Torrent is example for a peer-to-peer network application, right? Peer-to-peer network application, right? If you want to download 1 TB application, right? Then let's assume, right? Wait, right? Give me a minute. Right. Okay. What we are discussing about this peer-to-peer. Right. If you want to download this 1 TB file, maybe this may be a film or maybe some kind of, let's assume some kind of document, 1 TB document, right? Then in torrent networks, right, what it was happening, right? It was stored in some kind of not only a single computer. This is, let's assume you want to download. This is you, right? Client mean you, right? Then, right? Then what is happening? Another clients are available, right? This, let's assume these are clients. We have, let's assume likewise, right? 100, right? 100 clients. This is you, right? This is, sorry, right? This is you, right? This is you, right? Then in this torrent technology, in this torrent application, right? This distributed application, this torrent distributed application, what is happening? This 1 TB file is now requesting to the torrent network by you. Then what is happening? This one is sending some part. Let's assume 100 megabyte will be download from this user. Then another 100 or maybe 50 megabyte will be download from this user. Then another some kind of storage is maybe assume, let's assume another 100 megabyte will be downloaded by this client, right? This client by you, right? So likewise, in this case, this 1 TB file you are requesting is not download from the single phase, right? Right? It is downloaded from some kind of different places, right? So in this kind of distributed system, there is a nothing called servers, right? There is nothing called servers. All are working as client and servers, right? That means this one is working as the client and also server, because now you are also like that. You are also downloading this file from some other client, right? If some other client want, let's say this is another client, right? He can download the same file from you also, right? From you also he is downloading, right? This is some kind of what is called as, this is what we are calling as peer-to-peer, right? Right? No centralized authority or no centralized, not authority, no centralized mechanism, right? It is truly distributed part, right? It is truly a distributed application, right? No servers like this. Here we discuss about 3 servers, but here no servers in this torrent, in this peer-to-peer networking, right? There is no servers. There is some kind of application is running. Then through this application, all clients are working as servers and clients, right? That means there is no separate server machine, right? That is all idea. That is a very good example for this distributed application. This peer-to-peer network is, we are telling here as truly a distributed application, because there is no servers in this kind of, especially in this torrent, there is no server machines, right? No servers like LMS server or any other servers or server farms, nothing, right? There is nothing called server farms, right? Right. That is the idea. Right. Right. This is some kind of a graphical representation here. Client invoke individual servers, right? Then these are 2 server machines, right? These are denoted by process, right? These circles are denoted by process, blue circles, right? These are computers, right? This rectangular box are denoting this computers, right? Then you have 2 server machine. This is some kind of graphical representation for easy understanding, right? Then you have 2 server machines and you have 2 clients, right? Then what is happening, right? The clients are done some kind of invocation, right? Clients are doing some invocation. They are actually they are requesting something from the server. Then server will be give some kind of result. Let's assume if you done Google search, right? Google search, then that is some kind, if you press enter, if you type something in the Google taskbar, Google search bar, right? Whatever, right? And then you type enter, then that will be some kind of invocation or the request for the Google servers, right? Then let's assume you are, for you, it is responding one server machine, right? Then it is sending some kind of result to you, right? If you search something like cricket, right? Cricket, if you are searching word cricket, then it will show some result about cricket, right? This is the same idea here. Then what happened? Then the interesting story here is, then you are searching for the cricket, right? CRICKET, right? Cricket. Then you send that request to here. This for this server machine. This is some kind of one server. Let's assume Google server, right? It's situated somewhere. Let's assume it is in India, right? It is in India. Then you are searching cricket, but unfortunately, this server machine don't have any result about cricket matches, right? It is don't have any searches, or we call it as any records, right? If you learn database management system, DBMS, you will learn these records, right? In database, there is some kind of records and caching, those things you will learn, right? Then what happens if there is nothing find in this server about cricket, right? About cricket, then he will forward this request to any other server. Maybe this is, let's assume USA one, right? USA server, right? USA server, then it will again, right? Passing, or he is requesting, right? Data from this server machine, right? Also, that is the total idea here. Then this machine don't have that answer, right, about cricket. Then it is taking this searches or this information about the cricket from this server, right? Likewise, this is some kind of client invoke in individual servers, right? How these clients are invoked with the server machines. That is the idea that I want to give you, right? Then this is some kind of, we are telling as server architecture, right? Now we are discussing about a typical distributed application based on peer process, right? I also explained this one, right? Then what is happening here, right? This is, we are calling as peers, right? In here we discuss, these are we call as peers, right? In this peer-to-peer network, right? We call this as peers, right? Peer 1, 2, 3, 4, right? No centralized server machine like here. Here we have server machines, right? In this client server architectures, right? Client invoke individual servers. That means client server architectures, we have server machines. But in this distributed application, in this scenario, we don't have server machines, right? We have all peers in our network, right? 2, 3, 4, right? Here, peer 5, right? 5 and n, right? N mean any number of peers, maybe 1,000, 100, any number of peers can be available in a certain set of network, peer-to-peer network, right? What is happening in here? This means these objects, these are some kind of objects, maybe let's assume files, right? Objects may be files, document, anything, right? Maybe video, any other, anything, right? So this, according to here, we noted, we type this as shareable object. That means these are the objects that can be shared within the peer-to-peer network, right? Then what is happening? Anyone can share or distribute data with anyone in the network, right? If this peer 2 want to communicate with peer 3, it is happening, right? It is possible, right? Also, peer 2 can communicate with peer 4. If we want peer 1, with peer 1, he can communicate, right? Then what the interesting thing is, they can also share this shareable objects. These objects, anyone can share with any other, right? That is what we are calling as peer-to-peer network, right? That is no some kind of centralized server machine in this architecture. That is the total idea. Here we have server machines. Here we don't have centralized server machines. objects or the shareable objects we can share with anyone in the network. That is the total idea. Right, that is some kind of introduction or some kind of very brief introduction to what we discuss about this distributed computing. That is some kind of brief idea for this distributed computing. Right. So, right, next one is, I think, next topic we have here is grid computing, right? Distributed computing. Now, we discuss some idea or some introduction about this distributed computing. Then we are going to discuss about this grid computing, right? Okay. Right, grid computing. Right, this is some kind of definitions or some kind of idea, right? Right, webopedia.com, right? A form of networking, unlike conventional network that focus on communication among devices, grid computing harness unused processing cycle of all computers in a network for solving problem to intensive for an standalone machine, right? So the idea here is grid computing harness unused processing cycles, right? If you are, let's assume normally, I don't know what about you, right? In my case, right? So my computer, normally my laptop computer is, when I turn on my laptop computer in morning, the whole day it is turned on and the laptop will be shut down when I was planning to go to bed, right? That means nearly 12 to 15 hours it is working for a day, right? So my computer has some kind of computing power and it is have some kind of networking facilities. So, but it is not using by myself or any other, right? And when in a certain day, right? I use it one when I want, right? If I want to send email or do some kind of work, then I am used. Then what I am going to, if I am went to lunch or if I am went to some meeting, maybe if I am went to some kind of network troubleshooting or maybe some kind of homework, then I am not using my computer, right? But it is normally turned on. I don't know what is your experience, right? Normally it is turned on, right? It is turned on. Then this grid computing is coming with this idea, right? For the harnessed unused processing cycle, right? In that time, the computer is turned on, and but this computing power is not used by anyone, right? It is not using by anyone. This computer is in idle situation, but it is not using by anyone, right? So computers in network for solving problem to intensive for standard machine, right? So there's this is some kind of large concept that I don't remember the name of that scientist. He told that can't we use this processing power in the idle computer? The computers right? Can't we use this processing power and memory to do some kind of scientific calculation, right? That's the idea, right? So begin this idea. This idea is the main starting point for this grid computing, right? Right? Then IBM, right? Grid computing enables the virtualization of distributed computing, right? And data resources such as processing, right? Network bandwidth and storage capacity to create single system image, granting users and applications seamless access to vast IT capabilities, right? What is the idea here? Let's assume my computer, right? My computer is now in idle place. Now I am taking lunch. Now it is not working, right? It is not working. I am not taking any work. I am still not look after about that. It is turned on, right? Then what I can do, I can connect my computer, right? I can connect my computer or my laptop to some kind of grid computing, right? some kind of grid of computers. I can connect. What I can do, I can install some kind of application inside my computer, and I can, right, my computer, and I can turn on, I can install this application, and I can connect my computer into some kind of network, right? Some kind of network, right? This is some kind of network, right? Network, right? It's not clear, I think, right? Wait, right? Right. Sorry about that one, right? There's a call from your coordinator, right? Shall I am, he's checking that I am checking, I am conducting the lecture or not, right? Okay, what we discussing here is, right, here, right? Okay, let's say remove this one, right? This one, right? This is network, right? This is my computer and it has some kind of network connection, right? Some kind of telecommunication platform, right? Right? So then what I can do, I can install some machine, right? Right? I can install some machine into this computer, sorry, some kind of software, right? I can install some kind of software into this computer, that is, we call it as grid client, right? Grid client, and I can connect my computer to network. Then what I can do, the computer resources, that mean the computing power or the processing power, memory, I can share with the main grid computer. I can share with the main grid computer, right? That means this is one node, right? This is my computer and this is one node. Let's assume like this, right? There is a number of computers that is idle at the moment. That is idle at the moment. Let's assume 1,000 computers, 1,000 computers that is not using currently, and install that grid client software and connect into the internet. Then we have now 100,000 computers. Let's assume, right? Let's have 1,000 computers like this, like my computer. Then what we can do is some kind of person who is maintaining this grid, right? Right? This grid client application, he have a computing power, a collection of computing power of this 1,000 computers, right? That is the idea. He has the computing power of these 1,000 computers, right? It is connected through this network. Now this is a grid of 1,000 computers, right? Now this grid have, right? This grid have 1,000 computing power. That is a huge one, right? Then we can do some kind of large calculations in through this grid, right? If there is 1,000 computers like this, right? That is the idea, right? Enable the virtualization of distributed computing and data resources such as processing, right? Then what we had done here, right? What we had done here, we have manufactured or we have make a supercomputer, some kind of supercomputer, right? Using this unused turn on computer and the network, right? We had make some kind of large computer using this type of computers, not only my computer, some many other computers that is installed in the client application inside this application. Client application එක install කරලා නැත්නම් කරන්න දෙයක් නැහැ. Install කරලා තියෙන වගේ, right? We can take that into this grid. That is the whole idea about this grid, right? I will discuss some examples later, right? Then you will understand. Not about the computer grid. We will discuss about the power grid, right? Normally, now you know in Sri Lanka there is a centralized power grid, national grid of power, right? So that is a good example for this grid computing, right? right? So it is then this supercomputer we had made. However, right, in this supercomputer we can do virtualization, right? With the virtualization, in this is now a large computer, right? But it is not actually a large computer. It is some kind of virtual computer, virtual supercomputer. That is not a real supercomputer, but it is a collection of this kind of simple computing nodes, simple computers that is shared their resources with this grid, right? Now, virtually we have some kind of supercomputer, right? Then grid computer enable the virtualization. This is also a virtual computer, but inside here we can create some kind of virtualization machines, right? Virtualization computers, right? Maybe it is some kind of not much clear, but you will understand, right? Real one, right? Right? This is some kind of virtual computer, and we can use this computer, the supercomputer virtually made using this type of computer. We can use this computer for, right, processing, right? If you want to do some kind of large calculations, maybe let's assume in scientific research, if you have to do some kind of huge calculations, then you can use this computer, this supercomputer, virtually created supercomputer for the data processing. You can use that one for any purpose, right? Data processing, right? Right? Network bandwidth, right? Then you have huge network bandwidth, right? Then you are using huge network bandwidth and storage capacity, right? Then you can use some kind of hard disk spaces in these machines, and in the supercomputer, virtual supercomputer, that means grid computer. This we can say this one as some kind of grid computer, right? Supercomputer or grid computer, virtual grid computer. This is some kind of superpower computer, right? Then you can use this storage for storing some kind of information to create single system image, right? Storage capacity to create single system image, right? Single system image mean you can install one operating system here, right? Let's assume some kind of operating system you can install here virtually, right? Using these resources in the client, granting users and applications seamless access to the vast IT capabilities, right? Then what we can do, let's assume this supercomputer, this super grid is maintained by University of Vocational Technology, right? Your university, right? Institute of Vocational Technologies, right? Then there are scientists or the professors who is researching on what is the thing, right? About, let's assume, about astronomy, right? There's a professor or the team who is researching about astronomy, right? Then what they can do, they can use this supercomputer for their calculation, right? Then we can give some kind of access to the user, maybe Professor A, Professor B, Professor D. We can create some kind of user accounts in the supercomputer and the supergrid computer, and we can give some kind of accounts for them to do their research work, right? So actually, this is, I think, this grid computing concept was initially developed by, if I am correct, developed by MIT, Massachusetts Institute of Technology, USA, as their research, right? This is came into the picture, right? So that is the idea, seamless access to vast IT capabilities. Then these scientists have a large, huge computer, virtual computer. They can do their calculation, no scientific thing in there, right? Just as internet, just as an internet user unified instant, right? Unified instant. Sorry about that one, right? Unified instant of content, right? Via the web. A grid user essentially seen a single large virtual computer, right? Then what is happening, right? This is some kind of unified instance of content, right? This computing power, this super virtual grid computer have is some kind of unified instances like this, right? This kind of nodes or the instance are given their resources, share their resources with this computer grid, and this supercomputer having, right, large virtual seem to be, this supercomputer seem to be large virtual computer, right? So any other users who is accessing this one, maybe as my example, professors or the scientists, they are not knowing about this, maybe they much not aware about this infrastructure, about this unified instances or these nodes who are supporting them to create this virtual computer, but they only know this is, they are seeing this computer as a large virtual computer, right? That is the main idea about this grid computing, right? Then Sun Microsystems, grid computing is a computing infrastructure that provides dependable, right, dependable, consistent, pervasive and inexpensive access to computational capabilities, right? That means this Sun Microsystem, they are maintaining some kind of this kind of grid computing system, right? So this is some kind of infrastructure that providing dependable. Depending means this grid computer is depending on this type of unified instances or nodes, right? It is dependable, right? What happens is these nodes are getting low, the number of nodes or these unified instances are getting low. What will be happening? This virtual supercomputer power is getting down, right? Getting down, it is getting down. That is what we are meaning as dependable. So this virtual supercomputer was developed using this grid computing technology was dependable within this nodes or the unified instances, right? That is the dependable mean the idea. And the consistent, right? It is some kind of consistent, right? And some kind of pervasive, right? It is maybe sometime it is we have some kind of huge computing power, right? Sometime it is not much, right? Maybe if the discount is less, it is less, right? So these both things can be happen. It can be high or it can be low, and inexpensive access to computational capabilities. This is very inexpensive, right? Normally the people, that is this these computers, these nodes are owned by the people, right, in the society, right? That means this supercomputer taking the power of that power of the people's computing devices powers, right? This supercomputer is taking this idle computing nodes or the unified instances power, right? So that means for who are maintaining, let's assume Sun Microsystem or maybe UOBT, University of Vocational Technology, if they are maintaining this kind of grid computer, right? So they are using some others resources, right? That means that is very inexpensive, right? It is very low budgeted one, right? Then using very low cost without having computing power, they can make some kind of like some kind of virtual supercomputer, right? That is the total idea here. Right. Right. Then this is some kind of simplification of grid computing and electric power for your easy understanding, right? For your easy understanding, right? Let's take we will discuss about electric power grid, right? What is the electric power grid, right? Users or electrical appliance get access to electrical to wall socket, right? Normally the electrical appliance or the devices, electrical devices in your home are get access to the electric through wall sockets, right? With the socket again current, right? Through the wall socket, with no care or consideration for where or how the electricity is actually generated, right? When you are using some kind of electrical power in your home, even you don't know from where this power is generated, right? Monobalaga, Kalanitis in the Norocholede, right? You don't know, but you use it, right? right? You know, you are using calendar this the Norocchole, the I'm not the Lakshapana, you don't know, but you are using electricity, right? You have electricity, however, you don't know where it was developed, right? That is what we call as a national grid, right? All power plants that is situated in Sri Lanka are connecting to the national grid, right? The national grid will be some kind of single system like this grid computing, right? This grid computing, right? So this grid, like this Kalanitis Lakshapana, right? So these are the computing nodes, right? Who is giving power to the grid, computing grid, right? Like that, right? Right. So that is the whole idea here, right? The power grid, right? The power grid, this power grid, what is this grid is doing actually? Link together power plants of many different kinds, right? They are linked in these power plants. In our grid computing, this computing grid is linked in the computing nodes or unified instances of these computers, right? Right? Like this power grid, right? It is linking. So that is the idea, right? Many different kinds. They are not thinking what is this? This is Lakshapana power, or this is Norachola, this is generated from coal, right? This is generated from diesel, or this is generated from water. They are not thinking, right? All are power, right? They are using this power, right? What this grid is doing, this power grid is doing, this is making some kind of infrastructure, right? Or the links, making some kind of infrastructure and links together to power plants, right? To collect this generated power to a centralized location called national power grid, right? So this grid, right, users of client application gain access to computing resources, right? This is some kind of what is some kind of explanation for the grid, right? Users so client application, right, gain access to computing resources, right? The grid mean in computing, right? Users or client application gain access to computing resources like processing power, computer storage, and computer data sharing, right? Computer maybe data, right? And not only these things, we can share in applications in a grid and so on, right? This may be application, lot of things, right? We can share in this grid as needed with little or no knowledge of where those resources are located. Like in here, right? We don't know here what is where from this power is generated. Like here, we don't have, right? As needed with little or no knowledge of where those resources are located. We don't know where this processor is situated, where this storage is available. We don't know, right? So these applications are running where this application is situated, we don't know, right? Those resources are located or what the underlying technologies. Also, we don't know, right? To create this grid, right? Computing grid, not only this electrical grid. To create a grid, you need to have some kind of technologies, underlying infrastructure and some kind of technology, right? So who are the user of this grid computer, right? Don't need to know about these technologies or what are the hardware resources that is used for developing this grid or the operating system. What is the operating system they are using? You no need to think. UOVT have, right? UOVT have a grid computer, then you can use that one. You no need to think. What are the locations or the places that this hardware and this operating system is coming? What is the operating system running behind it? No need to think, right? You can do whatever you want from your computer, right? The grid links together computing resources, PCs, workstations, servers, storage elements, and provides, right, a mechanism need to access them, right? What is the grid is doing? Link computing, right? Link these devices or these machines, PCs, workstations, servers, storage elements. What is this grid are doing? They are linking these devices. And the second thing what grid is doing, provide a mechanism need to access them, right? It is provide some kind of interface or some kind of way to access by UOBT scientist, right? That is the idea. Okay. Right. I will discuss some point also, right? Right. One, share more than information, right? This is not only share information, right? It is sharing data, it is sharing computing power, right? So it is sharing applications in dynamic environment, right? We can share some kind of applications, right? You know, in Google Docs, you can collaboratively work. Not only one can work, some kind of collaborative people can work. Let's assume you have to do some kind of assignment. Then you have 3 group members in your team. What you can do, you can collaboratively work with that group. Let's assume you have to create a presentation. You can use Google Slides, right? Google Slides. Then you 3 collaboratively develop or make that presentation, right? Not a single one, right? Then what the advantages here is anyone can see this, see the changes in the application. Likewise, in this grid computing also, right? You can use application in dynamic environment, right? That means working environment, that is working, changing in an environment. You can use this application, changing application, right? Then multi-institutional, right? Multi-institutional, that means this grid computer not only for some kind of let's assume UOVT, right? UOVT has developed a grid computer. Then what they can do, they can share these resources with University of Colombo. Also, University of Colombo is telling we have a research to do, but we don't have computing power to do some kind of calculations. Then they ask him from the UOVT. Then what UOVT can do, they can share with their supercomputer with this University of Colombo, right? So that is the multi-institutional need, right? They can share these resources with these institutions that is available, right? Then virtual organizations, right? So what they can do, these are universities in the country, right? Then what they can do, they can collaboratively create some kind of grid, not on for the UOVT, not on for the UOC, right? You can make some kind of grid computer that is common for the whole university system. Let's assume you can create a virtual grid computer, right? Right? Common for collaboratively common, and you can work collaboratively with all universities in Sri Lanka, right? So that is some kind of virtual organization, right? Let's assume Sri Lanka University Research Organization, some kind of organization you can form and you can share this grid computer, right? That is the idea. Right, then efficient use of resources at many institutes, right? Use of resources. Then if they form that kind of common grid computer, then they can share these resources, right? If you, let's assume not UOC, right? Let's take Kelaniya University, right? Kelaniya, right? Kelaniya, right? Kelaniya, right? Then if you have common grid computer developed by with the collaboration with these 2 universities, Kelaniya and UOVT, then you can share these resources with this your 2 institutions, right? With these 2 institutes, you can share your resources. Right? People from many institutions working to solve a common problem. Right? Then, if there is any research, they can work collaboratively. UOVT and University of Kelaniya, they can work collaboratively. Right? People may from many institutions working solve a common problem. Right? That is called some kind of virtual organization. Right? They are working on common problem, maybe common research. Right? Right. Then join local communities. Right? Maybe for this this grid computer, right? Normally I can collaborate. I can share my computing power with this grid, right? That is this mean this join local communities mean, right? So the local communities can share their detail, or maybe they can involve with this research, right? That is conducted by UOBT and University of California. This local freelancers or so many other persons can join with this research, right? That is the idea. Then interaction with the underneath layers must be transparent and seamless to the users, right? So that means this now you are working in this this grid computer. Interaction with the underneath layer must be transparent, right? Maybe if you are using this technology, right? If I am going to collaborate for this one using that mean giving my computing power to this grid computer, then I need to have guarantee. I need to have guarantee that is not using any other unethical behaviors. I mean, maybe some person can hack my computer or store my data stored in my computer using this grid computing client or this grid computing infrastructure. They can access to my computer. Maybe they normally they cannot, but they can do some kind of try. If there is any bug or hole or backdoor in this client application installed in my computer, so so that kind of situation, there's a security issue, right? So it is better if they can publish this code lines, like in open source software development, the code is visible for anyone, right? Open source, right? Open source software development, right? What they are doing, the code is available, right? Anyone can see if there is any issue, any bug or anything is available in this code, right? Maybe if there is any backdoors, they can identify, right? So interaction with the underneath layers must be transparent. So we need to have this type of the infrastructure layer, and it must be transparent to any other for the collaborative person, all of the collaborative institutions and the people, or maybe some any other organization, maybe for the University of Colombo or University of Vocational Technology, University of California, maybe any other institute, maybe let's assume National Science Foundation. For this infrastructure need to be clear. For this all institute, there is no any misuse of these resources, right? And seamless to the user. So this is some kind of seamless access. They can collect number of virtual computing power seamless to the user using this kind of grid computing, right? All right. Then needs of grid computing. Needs of grid computing, right? Today science research is based on computations. It is obvious, right? If you, I don't know, do you have any research in this degree program? I don't know. That's why I'm asking. Can anyone can answer? Do you have a final year research to do in your university? In your
No, sir,
degree?
we have finally a project.
That means your degree is 3 years, 3 years.
Yes,
Yeah,
sir.
normally in 3-year degree programs, there is no normal research. When if you are conducting a 4-year degree program, then normally you have a research to conduct. Then you can realize if you are doing some kind of scientific research, right? Then how much of this computing power is needed, right? So then if you have some kind of good computers, or maybe some kind of a supercomputer, or maybe some kind of high-end computer in your organization, then that will be helpful for the research purposes, especially, right? Now, but in Sri Lankan context, then there is no much that kind of large computers are maintaining in, I think, University of Colombo, UCS is having some kind of server infrastructure for the research purposes. they are giving some kind of instances for the students, but I don't know any other institute or any other university in Sri Lanka. I don't know, maybe they are using, some other universities, they are not using it still, right? They don't have this kind of some kind of computing, not maybe grid, maybe some kind of internal cloud in the purpose of researching. I don't know, right? So science, today's science research is based on computation. We know it is a huge number of computations, right? That's why this technical development is fastly growing, right? So this is because we can do computing fastly, other than the history, other than the past, right? Using today modern powerful computers. Then data analysis, right? Therefore, the data analysis is needed, right, for the analyzing purpose of the data. Maybe if you are doing some kind of engineering work, maybe you are analyzing some kind of historical data, how this, let's assume, I know about the research about how this kidney disease is growing in Sri Lanka, especially in the north central area in the country. So for this kind of data analysis, they are using this kind of huge computing, right? Then data virtualization, right? You know, virtualization, we will discuss what is virtualization. For the virtualization purpose, we can use this with computing and collaboratively work with, I discuss about institutions. We can work collaboratively with the organization, right? Then computer simulations, you know, and modeling are more cost effective than experimental methods, right? Normally in, you know, in earlier time, if we want to develop, I will take a simple example, a car, right? If you want to make a car, right? Some kind of car, right? Let's assume this is a car, right? If you want to newly design a car, right? Then let's assume Toyota want to develop a new car for the 2023, right? Then what they have to do earlier, right? They have to draw that one in papers, and what they have to do, they have to manually create the arms, right? Whatever the gadgets, devices, doors, right? And all devices they have to develop, and they have to fit that one, and they have to turn on the engine, and they have to run it and check if it is working fine, right? So, right? And but with this simulation technology that now we have, computer simulation, what they are doing, there are number of separate software packages available. What they are doing, they are developing this car structure inside that simulation application, right? Right? Then they are developing in the simulation application, then they are simulating. They can push, they can put then 1,000 kilogram here. Here, they assume this 1,000 kilogram here, and check if this steel structure is capable of handling it, right? They can put some kind of 10,000 ton here, right? This is virtually, right? This is not real. Using this kind of simulation applications, right? They can check if it is, this steel structure is finally working for this car, right? Likewise, they can check virtually, right? Using this type of simulation application, right? Also this modeling application, right? So in earlier, we want to develop this material structure and check, but today, the development of this computer simulation and modeling, what we can do, we can simply design this one in a computer simulation and modeling software, and we can check, right? Right? So for doing this thing, we need huge computing power. Laptop, right? So you need huge computing power for this kind of run this type of simulations, right? So this grid is a good solution for that one, right? That is the idea here, right? Scientific and engineering problems are becoming more complex. Scientific engineering, right? These problems are becoming more, this is some kind of engineering, right? Mechanical engineering, right? So scientific and engineering problems are becoming more complex, and users need more accurate precious solution to their problem in shortest possible time. So we can use this grid computing because these problems are getting higher, more complex, and the users mean this company or maybe scientists need more accurate, that means more correct, precise solutions, right, to their problems. If they are designing this vehicle, after designing, right, then whole research was failed, right? That is also not, that is also money, right? Huge wasting of huge number of money and also time, right? So without designing this one, they need to have some kind of pre-simulate this work, right? For that one, we can use this kind of huge computing power. They need huge computing power like grid computing and cloud computing, right? Precise solutions to their problem in shortest possible time, right? They need to find this kind of simulation and solution with a short period of time, right? And data visualization, right? Normally, normally data visualization, if you are in some kind of organizations, like there are large screens and some kind of charts are there. They are every time watching the charts. If you have seen some kind of video in Colombo Stock Exchange, there are displays, right? There are displays are there every time watching these graphs and how these are behaving, how these companies are going up, or what are the companies going down, right? They are watching every time watching some kind of displays, right? These displays are showing some kind of graphs or some kind of information. So this kind of setup we are calling as data visualization, right? The how we can visualize this data, right? We need to find some data, we need to process data, and then in today modern world, data visualization is very important for the industries, right? Right, it's very important, right? Exploiting underutilized resources, right? Exploiting underutilized resources, right? Then they can get an idea, or we can utilize the computing power that is not using in this grid computing. As an idle computer that is not using, right? We can utilize that resources, right? So that is some kind of why we need grid computing, right? These are some points are common for cloud computing also, right? We will discuss those, right? Normally we cannot totally divide this grid computing and cloud computing, right? There are a lot of similarities, right? Right? Okay. Then next one, who use right, grid computing, right? Right, we have to discuss few things, right? So, right, shall we take a small break, right? Shall we take?
Yes, sir. Yes, sir.
Yes, how much time you need? How much time you need?
5 to 10 minutes, okay, sir.
5 or 10, right?
Yes.
You can tell, right? Then I can 10 minutes. All right. Okay. Then we will start at right now 5:39, 5:50. We will start, right? With when participating to the lecture series, because I think there is power cut there. I think a lot of issues. Maybe that is I don't know how these things will be over. Right? So I have this type of issues, right? Normally that's fine, right? Right. Prathipan, do you have anything to say? Right. Okay. Right. Okay. Then, however, I think try to participate for the lecture series. I think you about attendance. I think maybe I don't know what is the decision from your maybe. Yes, Prathipan. Do you have anything to say? Right. Right. Okay. Then we will be discussing about this grid computing. Then who uses grid computing? Right? Who uses grid computing? These are some kind of users, right? This is, I think, very interesting diagram, right? You can take the idea how much this grid computing is getting popular because of this scientific innovations or scientific researches, right? This some kind of nice graph, right? Uh, Detection and modeling natural disasters, right? I discussed about how modeling, right, or the simulating, yeah, right, simulations and modeling, right? Detection and modeling natural disasters, right? If there is, natural disasters like tsunami, right? If there is any earthquake in the sea, right, in the ocean, right, then what happened? They are using some kind of model to predict if there is any tsunami situation to certain countries. Then they are giving some kind of messages to there will be a risk of tsunami for this kind of beaches or this kind of countries, right? For that kind of purposes, they are using these grid computers, right? Huge computing power they need for this kind of calculations, because this calculation need to be given within the time frame, right? Tsunami ආවට පස්සේ කියලා වැඩක් නැහැ නේ, right? After happening the earthquake, then they have to analyze and they have to give the information quickly, right? For do these quick calculations, they can use grid computing. Normally they are using, I think, a lot of scientific organizations, a lot of universities are using, right? Normally in Sri Lanka, we are not using. What we are doing, we are taking some many other countries' information, right? Like in Sri Lanka, right? Then in the Pasco incident, right? Pasco incident in East bomb attack, right? Our intelligences don't know, but Indian intelligence is informing us there will be attack, right? There will be attack. Indian intelligence is informing us, right? They know like that, right? What it is happening to going, what it is going to happen, right? It is informed by so many other countries' intelligence, not our intelligence. They are informing to our intelligence, right? That's how they are powerful and good with these technologies and all of this, right? No, in this grid computing also, this disaster modeling, like tsunami information, we are using some others information. Normally in Sri Lankan weather forecasting also, lot of now not using Sri Lankan resources. Now a lot of people are using foreign resources, right? Weather.com or some other thing, right? So they are using this detection and modeling natural disasters, right? Not only tsunami, right? Maybe flooding, right? Flooding patterns in the world, right? Or in some kind of certain area, right? They are using, right? Then they are trying to mitigate this one, right? Using this kind of models, right? And what is this crystallography, right? Crystallography mean, I think this is about crystal structure, right? Lattice structure. I think you learn about lattice structure in O level in the crystal, right? So doing this calculation using these small structures, very small structures, but studying these structures is very huge calculations they have to perform for this crystallography. This is about studying about crystals lattice structure. So for this type of scientific, this is some kind of, we call mineralogy, right? It's called crystallography, the mineralogy area, mineral, right? This kind of researching area, right? Using this kind of grid computing, right? Then react applications, right? React application, that means nuclear plants, in a lot of countries they are using, even India, they are using these nuclear power plants, right? Now Sri Lanka don't have, right? I think there are a number of reasons why they don't have this type of, why we don't have this kind of reactors, nuclear. In the nuclear power plants, we have some kind of chambers like this, right? This called reactor. Here, thorium or whatever, uranium or some fuel will be, radioactive fuel will be used as the as the fuel, right? Radioactive, what is called element will be used as the fuel, right? Then I think normally within 1 kilogram of this uranium, I think it can be this power reactor. Normally in the power plant, we have several reactors, right? Maybe 5, 6, 7 reactors, right? Then you can generate huge amount of power. Normally, I think, I don't know actually, maybe I am thinking 1 kilogram of uranium can be worked with more than 3-4 months, right? So that is how this reactor is working, right? So in this reactor applications, right? So how this uranium reactors, how we can develop these reactors, right? This kind of researchers, they are using this grid computing for these calculations, right? To create new reactor, right? Maybe now they are researching on new reactors. I saw that some kind of video, I think from YouTube. Then there is some kind of reactor using nuclear fusion, right? Right. Nuclear fusion they are using. It is more heat than it is the heat generating in this reactor is nearly the heat of the sun, right? That is some kind of I think China was doing that kind of research, right? So that kind of research are going on. For that kind of researchers, they are using this type of grid computing, right? So react application, I think it is, I think I saw some kind of TV series about this nuclear disaster in Chernobyl. Now there's a war between Russia and what is the country? Russia and Ukraine. Russia and Ukraine. Before breaking down of the Soviet Union in 1992, these two are same union, right? This Ukraine and Russia is the same union. All are part of the Soviet Union. Then in, I think 1988 to 1999, right? 1989, right? 1989, maybe, I don't actually remember the year. However, the 1992 is the year the Soviet Union is destroyed or finished, right? So this Chernobyl nuclear accidents is the main reason for this breakdown of the Soviet Union, right? Then this Chernobyl is a city. That Chernobyl is situated at Ukraine, right? In that time, it was handled by the Soviet Union. After that, this total area was, I saw some kind of TV series, right? Right. So if you have time, you can. It is very interesting, right? How this nuclear problem will be occur, right? Chernobyl accident was happen, right? Likewise, then that was the main reason for the dividing this Soviet Union in 1992. Then again, there is a coalition now. That's why I would remember that one, right? Again, between this country, there is a war, right? There is a war now. It is very sad situation there. So, however, it is some kind of another story, right? If we got time, we will discuss, right? This is in this reactor application. In that Chernobyl case, I want to say there is an issue. There was an issue in that reactors, right? In that reactors, because of that, this reactor got exploded, right? Exploded, and huge radioactive things are exploded to the air, and that total area cannot be used. Even today it is not used, right? That area, right? Radioactive material are there. People cannot live there, right? So if you like, you can see this place, this area, the Chernobyl area is situated at current Ukraine land area, right? Ukraine country, right? That is some kind of history for you about this reactor cases, right? But I want to tell you in this subject, in this grid computing, we are using to mitigate this kind of accidents or the correctively design these reactors, right? If we are designing a new reactor, new technological reactor, we can use this grid computing. Scientists are using, right? And also not this grid, right? We will shortly discuss this cloud computing. Now cloud computing also using, right? So in physics applications, right? This is also, this reactor is also physics, right? It is nuclear physics, right? Physics application, in physics application, they will use this various number of researchers, right? Now science mean mobile phone is physics, right? There is chemistry also, but main thing is physics, right? So everywhere is physics, computing, anything, right? All of this is also, this computer science is a part of the physics, right? So this physics application, this computing is vastly using, right? I am not going to much explain. If it is, I'm going to explain, the time will be taken, right? Then weather forecast, right? Weather forecast, I discussed, right, about this weather situation. It is cloudy, or today it is will be rain, or maybe it is maybe any weather changes, or any what is called any hazards, or any other right, any issue, right? If you have any other problem or anything, you can have a hurricane or something, right? They are using, right, especially in hurricane, right? Hurricane prediction, you know, right now it is will be going with right, there is maps when you can check when there's any hurricane, right? Hurricane coming, right? Bengal book in again, right? Hurricane, right? They are developing some kind of predictions, right, using some kind of computers, right? Computing application, right? These are high computing. To calculate these models, they need high computing powers, right? So there's that kind of things they are using this grid computing, right? Right, if there is any hurricane, right, you can see the predictions, right? There will be some kind of different models they are showing. Maybe Lanka, right? It will be go through India, right? Tamil Nadu, they are predictions, right? For these cases, they are using this grid computing, right? It is some kind of uses of grid computing, right? Then some kind of types that now we are going to discuss, the type of grids. All right. Then first one, computational grid. Right. This grid provides secure access to huge pool of shared processing power suitable for high throughput applications and computation intensive computing. Right, provides secure access, right? And you need secure access, right? Computational grid. This computation grid mean this grid is using the purpose of computations, calculations, right? So provide this calculation. This grid will need to provide secure access, right, to huge pool of shared processing power, right? Maybe otherwise, if it is not secure, right, maybe some unauthorized person will be access this grid, then it will be maybe some kind of attack, or maybe data misuse, or maybe something, maybe some kind of disaster maybe happen, like Chernobyl accident, right? Secure access to huge pool of shared processing power, right? This is some kind of pool of shared processing power, right? They have enough computing power. That means pool mean resources are available as a pool. Whenever it is needed, it is allocated, right? That is the idea of pool, right? Pool එක කියන්නේ වතුර තියෙනවනේ pool එකේ, ඒ වගේ ඕන වෙලාවට ගන්න හැකි, right? It is some kind of storage, right, of the shared processing power. Processing power එකේ pool එකක්, right? Suitable for high throughput application. That means high performance application, right? Some application need high calculations, like high performance. Some type of application need maybe 1000 GB RAM, right? Likewise, right? 1000 GB RAM. This kind of applications are available, right? So to run this type of application, this kind of according to the load we are giving to that application, this RAM capacity and the storage capacity will be different. Then what we are doing, we are maintaining some kind of pool of the resources, not only the RAM processing power, RAM, storage, those things, right? High throughput application and computational intensive computing, right? That is the idea about this computation grid. Then data grid, right? Data grid provide an infrastructure to support data storage, right? Data storage, that is the simple idea. This data grid are used for storing data, right? Data discovery, right? And data storage, they are using for data storage, data discovery. If you are store some data, then you need to discover them, right? Then that is obvious, right? That is obvious. So data handling, then you have to handle that data, or maybe you need to take some report, generate some report. So this type of is also available, right? So the main purpose is storing data and manipulating and searching and some kind of simple virtualization, that kind of things using that kind of grid. Then data publication, right? If you want to publish the data, then that is, we can do data publication. And data manipulation, right? If you want to change some kind of records, then you can do that one. Of large volumes of data actually stored in various heterogeneous databases and file system. In grid computing, you know, these are not a centralized system. These are distributed among various computers, right? Various in volumes, right? Various geographical places. So data actually stored in various heterogeneous databases and file systems. So this data will be stored in various databases and file system, right? So that is the idea about this data grid and computational grid. Then next one is collaboration grid, right? Collaboration grid. With the advent of internet, right? With the advent of internet, there has been increased demand for better collaborations, right? Increase the demand for better collaboration. Right, we discuss about this collaboration, right? Collaboratively can work, right? This is the idea, right? Collaboration, maybe we discuss universities can create some kind of centralized grid, right? That is the idea, right? The main reason for this collaboration grid, the development of the fast growing development of this communication, basically the internet technology, right? This communication of internet is, this is because of this basic or the main communication platform in this grid computing is the internet, right? Has been increased demand for the better collaboration. Such advanced collaboration is possible using the grid, right? Such advanced collaboration is possible using the grid, right? For instance, persons from different companies, right? Different companies in virtual enterprises can work on different components, right? From different, we had discussed, right? Universities, National Science Foundation, maybe what else? What are the technological companies, like some many other engineering companies, ICC or MACA, right? Different companies in virtual enterprise can work on a different components, right? Of a CAD project, right? Component of a CAD project without even disclosing their proprietary technologies, right? If they have a CAD project, likewise, then the CAD project, like, let's assume they want to design a car, my previous example, right? Then what, there are a few universities and car companies, let's assume this is Toyota, right? And University of Colombo, University of Moratuwa and Toyota, they are working, right? Then they can decide using this CAD project, right? Different components, right? Then what happened, this University of Moratuwa is designing this wheel, right? He is individually designing this wheel of the vehicle, right? Then University of Peradina designed this, what is this bonnet, right? Likewise, right? The design, right? Then they can work on the same CAD project with different different instances, right? Same project, right? So also they can disclosing without even disclosing their proprietary technologies, right? Without sharing their company proprietary technologies. Normally, computer companies have like secrets, like Coca-Cola secret, right? Everyone is drinking Coca-Cola, right? No one is know, right? Everyone is drinking Coca-Cola. Everyone is know what are the ingredients, but no one is knowing how to create Coca-Cola, right? It is still a secret. It is still a secret. Now that is it is some kind of a proprietary technology from the Coca-Cola company, right? that is the industrial secret, right? Recipe no one is know, right? They know what are the ingredients, they know what are the items, but they know how to create it, that one, the recipe. So, right, or the how it is need to maybe some differences. First, they are using, maybe if they are using dal, they need to dry for the 200 centigrade. Likewise, they have some kind of recipe. No one don't know even complete of this complete recipe. Likewise, they can work in this CAD project even without disclosing, without knowing their proprietary industrial technologies or secrets, right? That is some kind of the idea about this collaboration grid, right? I think you got some idea about computation grid, data grid, and collaboration grid, right? Right. Then types of grids, right? We will discuss some types of grids, right? Okay, types of grids. Network grid. A network grid provides fault tolerant and high performance communication services. Right. Each grid node work as a data router between two communication points. Right. Provide data caching and other facilities to speed up communication between such points. What is a network grid mean? Fault tolerant. Right. That means in this network grid, right, if some node is getting down, right, then that will be taken by some any other node. Let's assume this one is done, this node is this, or this machine was computing this P1 calculation, process 1 calculation, right? Then suddenly it was faulty. Then what happened? This fault tolerant means that quickly this another node adjacent to it or any other computing node near to that one will take this P1 process and that one is processing it, right? So that is fault tolerant. And high performance communication, right? We can do if it is communication is good, right? Network is good. In this network grid, we can do high performance communication. We can use communication services. So the purposes, this network grid. Each grid node work as a data router between two communication points, right? Each grid node work as a data router, right? So this each grid node work as a data router, right? That means in this network grid, the routing means that is, if you learn networking, you may learn about this routing, right? So if this process is not working here, cannot process here, then this node is routed that process to here, right? If this node is busy, sometime maybe this node is busy, then what this node is doing, this is any another work like P2, then coming to here, but he reject it, but he route it to this place, right? Then this node is telling, no, here I am busy with some work, please go there, right? It is directing here. That is called routing, right? The simple idea about routing, right? Router between two communication point, right? These nodes working as routers, right? Points providing data caching and each other facilitate to speed up the communication between such points, right? So now he know caching means now he have some kind of small database, right? Small caching means it is storing some kind of data, right? Caching, right? I think this is a huge concept, right? Caching, right? Caching, right? Caching, right? It's a huge concept, right? It is a huge concept. You need to learn much about this one, but I'm not going to discuss about that one. Simply what it is doing, simply it is storing some kind of data, right? Then why the P2 process is coming to here, right? He know now I am busy, right? I am busy, I cannot process, and he also knows any other thing. What is that? He know this adjacent node can do this process, right? That is some kind of caching data stored by this node about this node, right? He is storing some caching data about this node, right? Then why he is no, okay, I am busy, but my friend is free. I am passing this please go to here. He is routing this one, right? So that is the idea about this data caching, right? I'm not going to discuss much about this one. There are several stories and several discussions, scientific background about this data caching, caching algorithms you have, right? If you are interested deeply in, right, normally I don't know in any university you can learn this caching algorithms, but you can study, right? If you have basic knowledge about computing, you can study, right? And other facility to speed up the communication between such point, and other facilities to speed up the communication between such point, right? Then some many other the one thing is data caching, another thing is routing, right? These things will be speed up the communication, right? Otherwise, then what will happen if this node is not maintaining a cache, P1 have to go here, then reject him. Then P1 come to out and he will go to some any other, right? Here. Then it is also again busy, right? Again busy. P2 come to here and it is also again busy. Then what happened? Then he will send to some other place. Likewise, that is time wasting and network bandwidth unusable, right? The network bandwidth will be very busy if this kind of situation occur, right? You will learn these things, I think, data structures and algorithm, right? And network routing, right? We call that kind of protocol as data flooding protocol, right? That flooding will be happen, right? To mitigate that one, this one is maintaining cache. Then simply he is free. My friend is free. He is directly say in P2 to go to here. He will do your process, right? So that is that will be speed up this communication between such points, right? That is the idea about this network grid and utility grid. This is the ultimate form of the grid, right? The utility grid, right? This is some kind of ultimate. This is the total idea about the grid, right? Which can not only data and computation. It is this is some kind of terminology, right? This is some kind of terminology. Is the ultimate form of grid, which not only data and computations cycles are shared, but software, right? Software or just about any resource is shared. Not only data, not only computation cycles or the computing processing power, not only the software, not only any other resources, anything. This utility grid means it will share anything that it is available or having, right? That is the idea about this utility grid. The main service provider through utility grids are softwares and special equipment, right? Provided through the utility grids are software and special equipment, right? Normally special software tools, scientific tools. These scientific tools are not used by much of the community. Community are using some kind of general software, but this special equipment they want to supply, they will use this kind of utility grids. For instance, the application can be run on the machines and all the users can send their data to be processed to that machine and receive that result back, right? Normally, if your computer don't have, if you are a researcher, you don't have enough computing power to do your research calculation, then what you can do, you can log into some kind of grid and you can send your problem to the grid computer and it will be processed that one and give you the result with shorter time period, right? With shorter time period, right? I know that it is, some people maybe, some student maybe think, oh, is there any calculation that type of time is taking? I want to say yes, right? It's normally multimedia students, I think they know when they are making some kind of video, then they want to what is called that one, render that video around how how much time it is taking, right? Then if you have some kind of grid, then you can do that one fastly and easily, right? That is the idea, right? Then that is utility grid, right? And these are some kind of components that we have, grid components. Then users, right? Right, groups and sites, right? These are some kind of components that we have in the this ecosystem of the grid, right? And then users, large and dynamic population, right? Now we have large and changing users and changing resources, right? Different accounts at different sites, right? And normally for a grid, there may be different scientists. That means different for each scientist maybe have different accounts, right? They have different accounts and different sites. Maybe a one grid computer maintaining some kind of different interfaces or sites, right? This is some kind of web-based solution since there is some kind of sites available to access, maybe some kind of IP addresses that's available to communicate. And personal and confidential data, maybe inside this grid, users are inputting personal and confidential data. Maybe scientists are using some kind of personal information of some kind of databases and to the process, right? So this kind of database may be your gene pattern, maybe your identity card number, phone numbers, right? Even your favorite thing. Likewise, this some kind of personal confidential data, maybe your health records, right? What are the problems you have in health situation? What are the illness you have? Likewise, they have some kind of personal and confidential data. And heterogeneous privileges, right? Roles. Maybe in this grid, maybe there may be some kind of person who are the administrating the grid. Maybe they have full access to this grid computing system, right? Maybe some kind of users are also available. They have some kind of limited access. They don't have full access. Likewise, normally in a computing system, we are maintaining some kind of roles, or what we are calling as privilege levels, right? Then desire single sign-on. I don't know if you are familiar with the single sign-on. We call it as SSO, right? Maybe some kind. This is some kind of SSO means some normally a server, right? Normally SSO server, right? This is not doing much thing. This server is only doing some kind of validating purpose, right? If you can create some kind of if you let's take as your institute, your UOBT university, right? They have some kind of SSO mechanism for the authentication of this, especially these Zoom accounts. They are using this SSO account, right? Normally UOBT have this SSO account. They are validating these accounts to this SSO server, and your university also have this kind of server, right? Your IT division, right? SSO server, right? I think I don't know actually what is the software they are using in this server, but there is, right? There is a SSO server for the verification purpose. So for this verification work, also this kind of grid computing can also be used, right? But there's some issues, but they can use, or maybe for the accessing. The meantime, the accessing this grid computer, some persons can use this SSO server for the authentication purpose of this server. All right, then groups. What are the groups we have? Group data. Then what are the maybe some group of people or group of institutions, group of universities are working, group data you have, and access patterns. What are the how you can analyze how much what is the access patterns of the each institutions, right? You can access using the log file or whatever the thing, and the membership of the groups, and you can maintain the membership, right? You can use some kind of registration number or something, right? You have maintained, and then sites, right? Heterogeneous resources, right? Different kind of resources you may have. Then access patterns. What are the access patterns? Also about the sites, right? Normally, if you want to access the grid computer, you have to use some kind of grid site, right? So that access pattern and local policies. What are the policies and regulations that you have? and you have to maintain the membership of this grade, right? That is the idea, right? This is some kind of basic, don't think much about this. This is some kind of basic idea about the grid components, right? What are the components that we have? Right. The next one is cluster computing, right? I think it's the time. Okay, oh no, 6:26, right? 6:26. I think 4:30 to 6:30, right? So we have another 3 minutes, right? Okay, we will start in this, stop at this point, right? If you have any question, you can ask. We have a few minutes, right? Otherwise, we can stop at this point, right? I think some students have a power cut, right? Maybe that is now it is power cut and polling, right? Queues, right? It's a normal case now in Sri Lanka, right? We are in a very difficult situation, right? We are in a very difficult situation as a country now. All are fed up, right? All the life is not easy. I know this, right? So I think I don't know what will happen. Maybe very challenging future days or future months, future years will be coming, right? Okay. Right. Since I thought that you don't have any questions, right? I think, right? If it is not, I will stop sharing. Right. I think we discussed a lot of things, right? I think I try to describe my best, right, and give the idea. I think if it is not much clear, right, then you can learn your own self, right? You can search yourself and you can learn also, right? Right. Okay. Shall we then wind up?
Okay, sir.
Right. Okay. Thank you. Right. Thank you for the participation and wish you a good night and be careful with the work, right? And also do studies, right? Do
Okay,
studies,
sir.
right? Okay, let's meet. I think tomorrow we have, right?
Yes, sir.
Tomorrow we will discuss, right? Okay, meet and thank you, right? Thank you very much and good night.